Okay, here we have section 7.4, exercise 14. This one, we're told that y equals natural log of e to the x plus 1 over e to the x minus 1. And we want the arc length from log of 2 to log of 3. So we can take the derivative, y prime. Well, that's 1 over the e to the x plus 1 over e to the x minus 1. So that's the reciprocal of that. We get e to the x minus 1 over e to the x plus 1. And then times the derivative of that fraction up here. So the derivative of the top, e to the x times the thing on the bottom, minus the derivative of the bottom, e to the x, times the thing on the top, e to the x plus 1, all over e to the x minus 1, quantity squared. Okay, we can do some simplification here. We've got that e to the x and one of those. So the top is e to the 2x and minus e to the x, and then minus e to the 2x and a minus e to the x. And that's all over e to the 2x minus 1 when we multiply those two together. So those disappear up there, and we get a minus 2 e to the x over e to the 2x minus 1. So there's y prime. Now we need the square root of 1 plus that thing squared, so 4 e to the 2x over e to the 2x minus 1 squared. I'm not going to put the integral stuff around it. I'm going to mess with this first. Okay, so what is that? Getting a common denominator and multiplying that thing out on the top, we get e to the 4x minus 2e to the 2x plus 1, and then plus 4e to the 2x. And that's all over e to the 2x minus 1 squared, and that's all under the square root sign there. So simplifying the top, the 2e to the 2x, the negative that plus that, so we get e to the 4x plus 2e to the 2x plus 1 over e to the 2x minus 1 squared. But that thing on the top is a perfect square, I guess. So that's e to the 2x plus 1 squared over e to the 2x minus 1 squared. Now, I'd like to just take the square root, but we have to be careful. Both of these numbers are positive as long as x in the bottom, the only one we have to worry about. As long as x is bigger than 0, we're good, and x started at log 2, so this thing on the bottom is never negative, so we can just take that square root, and we end up with that whole thing becomes e to the 2x e to the 2x plus 1 over e to the 2x minus 1. So our arc length A is the integral from log 2 to log 3 of e to the 2x plus 1 over e to the 2x minus 1 dx. Now, you'd think we can't do that, but actually, Here's a nifty little idea. Let's factor e to the x out of the top and the bottom. So this is log 2, log 3. And we have e to the x times e to the x plus e to the negative x. Now the reason I thought about doing that was because this e to the x plus e to the negative x looks a lot like, a nice hyperbolic cosine. And then e to the x times e to the x minus e to the negative x dx. And so those disappear. And we just end up with that fraction. And amazingly, we can do this one. Because if we let u equal e to the x minus e to the negative x, that thing on the bottom, then du is e to the x plus e to the minus x dx. The thing on the top times dx. Amazing. And so, what we also need u of natural log of 2 is equal to e to the log 2 minus e to the negative log 2. Well, that is equal to 2 minus 1/2, or 3/2. And u of log 3 is e to the log 3 minus e to the negative log 3. Well, that's 3 minus 1/3, or 8/3. So this whole thing just turns into the integral from 3/2, 3/2 to 8/3 of du over u. Who'd have thought? So this is equal to natural log of u. Now I don't need the absolute values because I know my two limits there are positive numbers. So this is from 3/2 to 8/3. This is natural log of 8/3 minus natural log of 3/2. So this is the natural log of 8/3 divided by 3/2, which is the natural log of 16 over 9. Wow. Okay, so log of 16 over 9 supposedly is the answer. I actually, in this particular case, had worked this out because I got a, back here when I did this the first time, I didn't do this nifty idea right here. I tried it a different way, and I think when I did that a different way, well, I know when I did that a different way, I ended up making some sort of numerical error because I didn't quite come up with the right answer. I got, this is like log of a little bit less than 2, and I had about twice that. So I had an extra 2 in there somewhere. But we can check this and see that it is correct. Natural log of 16 over 9. So I put, our function into Desmos, did the arc length integral, and got 0.575. And when I took the natural log of 16 over 9, I also got 0.575. So there is our answer. It doesn't, from a technology point of view, it really doesn't take much. From a symbolic point of view, yeah, it took a little work, and it needed a little tricky step in there to kind of see what was going on. This was a nice step here to get something that we knew how to take the antiderivative of through substitution. So there we go, number 14. Whoops, missed.